One application to the calorimetry. Here, I want to find the total energy required to convert 1 gram cube of ice initially at T equals to minus 30 to steam, to gas at T equals to 120. So, in general, if you want to convert one solid to gas, you have to convert, first of all, from solid to liquid. And after that, you go from liquid to gas. You cannot go directly from solid to gas. So let me divide the procedure to many steps. First of all, here we have y-axis, the temperature in terms of the energy added. Initially, we have the cube at minus 30. Okay? I want to add some quantity of energy to convert the ice from minus 30 to 0. So here we have pure ice, and here we have pure ice between minus 30 to 0. And we have one phase. So in the region A, we have only one phase. In this case, between minus 30 and 0, we have to use Q equals to mc delta T. Okay, now I am talking in general. After that, I take each case and we solve the problem. Second, when we have the ice at 0 degree, in this case, if we give more heat, this quantity of ice will be converted to liquid. We have melting. Between when we have two phases, when we melt the ice, in this case you have some quantity of ice, and this quantity will be converted to liquid. So between this point and this point we have two phases. Okay, we can say the zone B. In the zone B we have a change of phase. As we have a change of phase, we have to choose this equation, Q equals to L delta M, because we have a change of phase between solid and liquid. And here we have a fusion, we have LF, okay, as a zombie. Now at this point, we have only liquid at a temperature equal to 0. We give heat now to increase the temperature from 0 degree to 100. At this point, we have the liquid at T equals to 100. Okay? To convert the liquid from 0 to 100, we have only one phase because we have liquid to liquid. Okay? In this case, we have to use in the zone C, Q equals to mc delta T in the case of one phase. Now we have the liquid at 100. To convert the liquid from 100 to steam at 100. So between this point and this point, T is constant because we have a change of phase, and we have to use the equation Q equals to L delta M because we have two phases. We have the phase liquid to phase gas, steam. Okay? At the point E, we can say at this point, we have a steam at 100. We have to give some quantity of heat to increase, to convert the steam from 100 to 180. So we have from steam to steam. So we have one phase, and we use in this case, in the zone E, Q equals to mc delta T. So in general, you have to know, if I go from the initial state to the final state, if we go from one phase to another phase, you have to use Q equals to M delta L or L delta M. If I go from one phase to the same phase, liquid to liquid, solid to solid, gas to gas, you use Q equals to MC delta T. Okay? Let me start. First of all, in the first case, in the zone A, where I want to convert the ice from -30 to 0. I give a quantity of energy to increase the temperature from -30 to 0. Between this point and this point, we go from ice to ice. This ice is at T initial equals to -30, and this ice is at T final. T final, we can say T1, T2, okay? It's not the final, it's the final here, equals to 0, okay? We have the same phase, ice to ice. In this case, we have to use Q equals to MC delta T, okay? Here we have ice of 1 gram, so we have 10 power minus 3 kilogram. C of the ice is given, okay? You have the table, you can see the value of T, of C, and you put it directly. We have, okay, let me look, C of the ice. We go back also here. We have, let me see. Okay, the ice is 2090. You see here, ice in general, -5 or -30. You don't have a lot of change. And it's 2090. Okay. So we put here the value of C 2090 times delta T equals to T final minus T initial. T final equals to 0 minus T initial equals to -30. Okay, we calculate, the value will be 62.7 joule. Okay, so this is the quantity needed to convert 1 gram of ice from -30 ice to 0 ice. And this is the energy added to the system. So on the x-axis, which represent the energy added, we put 62.7 joule. This is the energy needed. The second point, we have to convert this 1 gram of ice from 0 ice to 0 liquid. Okay, look here. At this point, we have total quantity. We have a pure ice. I want to convert this one to pure liquid. So we have two phases, ice, liquid. In this case, we have to use Q equals to L delta M. Okay? We say Q in the phase B, here we have phase B. QB equals to LF, you know, L fusion of the liquid. Here we have in general of the liquid ice. If you look the table to find the value of L, F, L of the liquid, we have it's here, okay, equals to, here we have L delta M, we can say L fusion, latent heat of fusion, equals to 3.33 times 10 power 5 joule per kilogram. Okay, we come back here. LF delta M equals to M final minus M initial. You know, delta M is a change of mass of the higher phase. I told you in this case between solid liquid, the higher phase is the phase of the liquid. So L final of liquid minus L initial of liquid. You know, initially we don't have liquid. So L initial of liquid equals to 0. And finally, L final of liquid equals to the mass of the ice, because the total quantity of ice is converted to liquid. So this mass, you will not lose a quantity of mass. You will get the same quantity of mass, initial and final. If all the quantity is converted to liquid, so the mass of the liquid must be equal to the mass of the solid. So in this case, the mass of the liquid final equals to mass of the ice, okay, equals to 10 power minus 3 kilogram. We have LF, we have M final, this one equal to 0. We do the calculation, you get the energy equals to 333 joule. This is the energy required to convert this quantity of ice from 0 to 0 liquid. Okay, it's from here to here. I need 333 joule. The total energy needed from 0 to this point equals to this one plus this one. Okay, it will be 396. We can say here directly, from here to here I need 62.7. From here to here I need this value. The total from initial point to the final point here, it will be 396. Okay, now we go to the third step. Now at this point, we have a liquid, pure liquid at 0 degree. I want to add a quantity of heat to increase, to convert the liquid from 0 to 100. Okay, we have from liquid to liquid, so we have only one phase. We use Q equals to mc delta T. Here we have only liquid, so we have mass of the liquid equals to 10 power minus 3 kilogram. C of the liquid you can find from the table. Delta T equals to T final minus T initial equals to 100 minus 0. Okay, the answer will be 419 joule. This is the quantity needed to convert the liquid from 0 liquid to 100 liquid. Okay, it's from here to here. I need 419 joule. The total from here to here equals to 815. Okay. Okay, we go to the next step. Here we are at this point where we have a total pure liquid at 100. If we if we give more energy, this quantity of liquid will be converted to a pure gas, steam, from this point to this point. As we have two phases between liquid and steam, in this case we have the same T, 100 and 100. And the equation used must be equals to Q equals to L V delta M. You know, delta M of the higher phase. In this case, it's the steam. S, steam. Not solid, steam. Huh? LV, because we are between liquid and gas, we use LV. Between solid and liquid, we use LF. Be careful. You have LF and you have LV. So LV is given. You can see the table. You have LV of the liquid. Delta M equals to M final of the higher phase steam minus M initial of the higher phase steam. Okay? Initially, we don't have steam. So M initial steam equals to 0. And the mass of the steam equals to the mass of the liquid. Okay? So here, M final steam equals to the mass of the liquid. And we have LV from the table. You do the calculation. We have LV delta M. The value will be 2260 joule. This value needed to convert this quantity of liquid from 100 liquid to 100 steam. From here to here, we need 260 joule. The total from here to here, you do the summation, you get about 3000 joule. Okay, we have 3070 joule. Okay, now we are here at this point. At this point, we have only a gas, steam. I want to convert this one from 100 steam to 120 steam. So we are going from the same phase, steam to steam. In this case, we have only one phase, Q equals to M C delta T. We have steam, so M of steam equals to M of the liquid, okay? Equals to 10 power minus 3 kilogram. C of steam. So you can calculate, you can find C of steam in the table. Delta T equals to 120 minus 100. Okay, you do the calculation, you get finally 40.2 joule. Okay, Now, to calculate the total energy needed to convert the ice from minus 30 to 120 steam, you have to add Q total equals to QA of the zone A plus QB plus QC plus we have, let me see, we have QA, this value, plus QB plus QC plus QD plus QE. Okay, the total will be 3110 joule. It's a positive value because we add this quantity to the system. If we add the quantity to the system, it must be Q hot, Q positive. If you do the same calculation, and if you want to solve another example, to convert the same quantity of steam to ice, you have to follow the same procedure, but you opposite the trajectory. Okay, I give you an example. I want to go now with the same quantity from 120 steam to 100 steam. Okay, so another example, I want to go from this quantity to this quantity. In this case, we have steam to steam, so Q equals to MC delta T. Okay, you know M equals to 10 power minus 3, C of steam you can find. Delta T equals to T final 100 minus 1, the initial is 120. So the value will be negative. Okay, why? Because we decrease the temperature. In this case, you have to release the quantity of heat. The energy is released from the system. In this case, it must be negative. So if we go from up to down, we release the energy and Q must be negative. If we add the quantity of heat, so it must be positive. It's very important, this problem, to understand when can we use Q equals to MC delta T when we have only one phase, and when you use Q equals to L delta M when we have a change of phase. And you have to know delta M is a change of mass of the higher phase. Between solid liquid, we have liquid. Between liquid gas, the gas. Okay?